All right. Good evening, everyone, and welcome to the October meeting of the RASC Ottawa, RASC Ottawa Centre. For those who don't know me, I'm Mick Wilson. I'm the ringmaster tonight, and we have a fairly busy schedule. Bit of centre business to cover early on. Then we'll lead through to our guest speaker, Marion, from here at RASC. Monitoring climate change from space. Normal break, we then have Simon reviewing science prospects on the moon in the lead up to Artemis. Gordon Dewis is going to give us a user's run through on the RASC Discord, and then we've got lots of observations. So to all the speakers tonight, please, I'm asking, be aware there are a bunch of people coming up behind you, and we may have to move some of the business across to the next meeting. It's that full of an agenda. Yes, we are recording for posterity. Those online, if you want to ask questions of the speakers, please use the Q&A. Anything you put in the chat box is visible to everybody for all eternity, and raise your hand is disabled. 86 new members, 9 in the last month. Including a lot of McAvoys, so welcome. Do we have any new members here? Not a single one. One? Yay! Okay. 2, thank you. So the new members are obviously aware of all the benefits of becoming a member of the RASC and RASC Ottawa in general. My strong point is always it's the people, not only the guest speakers like Kaz, who's there and there, the normal membership, whether they're observers, scientists, whatever, they're all here to help you. You get practical and theoretical advice and so on that's second to none. We have physical assets available to members, including our loan library. It's now up to about 40 telescopes available free of charge to members. We have the media library out the back here behind the curtains. That'll be open at the end of the meeting, and you can go and ask Estelle for anything in particular you're looking for. We have the members only Fred Lossing Observatory out near Allamont. That's members and guests. It's a semi-dark sky site, less than an hour away from Ottawa, so that's a good asset. And then, of course, as a RASC member, you have access to a variety of certification programs that are meant to help you develop your observing techniques. As far as printed media goes, we have our own frisky little monthly newsletter called Astro. Is Gordon here tonight? Thank you. You and I will have words. There's the bi-monthly RASC Journal. Now, he's accusing me of having screwed things up, that's all. I've changed it. Yeah, I'll come back to you. Just leave me alone. We got the bi-monthly RASC Journal, somewhat more scholarly. That is available as a print product. You get the online version as part of your membership, pay a little bit more, you can have the printed version. And then there's the annual Observer's Handbook, which is a long-standing treasure of RASC. Additional benefits, there is a RASC Ottawa members only Discord available. Lots of chatter on there amongst the astrophotography groups. There are many other streams, and it's a very informal way for members to exchange information. As a member, you also get access to the Astrospheric app. This is specially engineered for observers and provides multi-model synoptic forecasts on points such as cloud cover, transparency, and so on. That would cost you normally $60 as any other user, but you get it free through RASC. So welcome to the club. RASC memberships at the moment, $113 for normal people like me. Family membership, $107 and a bit, plus a per head fee for each family member. And then as a student or anyone under 21 years old, it's $72.40 a year. That almost gets you astropspheric anyway. So it's worth it. Annual dinner meeting. Oscar, you want me to do this or?
Thanks, Mick. So, as I did announce it last week, or last month, I should say. But we had much smaller attendance. I hope we have more folks around this month. But we're having our annual dinner meeting once again at Algonquin College, Friday, November 22nd. So mark your calendars. We'll begin the night at around 6 p.m. with cocktails and dinner served at 7. It's going to be a buffet style dinner, with our main courses being either a chef carved roast sirloin of beef au jus, or a grilled vegetable lasagna for those who don't wish to eat meat. There'll also be an assorted serving of side dishes, cheeses, desserts, etc. We've invited Dr. Jesse Rogerson and Dr. John E. Moore as our guest speakers this year. And the abstract they provided for their talk is as follows. Our ancestors experienced the 5 classical planets of our solar system only as points of light in the night sky that appeared to wander amongst the fixed stars. Today we know these places, and even a few more that our ancestors did not, as worlds in their own right through the data returned from our robotic explorers over the past 62 years. How would those planetary environments appeal to our 5 senses if we were to visit them in person? In this talk, we draw on our research and storytelling from our book, Daydreaming in the Solar System, to help us tour the solar system and understand what it would be like to see, hear, touch, smell, and even taste immersed in the environments of our planetary neighbors. Through this journey, we will obtain a keener understanding of our universe as at a human scale that will deepen our appreciation for our own home, the Earth. So yeah, that'll be the talk given by our 2 guests. They will be selling copies of their books as well as having a book signing if for anyone interested. As we do every year, we'll also be handing out our annual awards. And if that's not enough to convince you to come, we'll also be handing out some door prizes. I've been in touch with Skywatcher, and they very kindly donated a beautiful telescope for us to give out as a door prize. It is, let me get the details on it here really quick. Where did it go? I just had it. It is oh no, I lost it. Yes, it's a 25th anniversary SkyMax 127. So it's a 5-inch Schmacktusov Cassegrain, I believe. Beautiful telescope, limited edition production. I think they're only producing something like 500 of them. So tickets will be $65 per person when purchased by cash. I'll be selling tickets at the break. You can also purchase with debit or credit if I can get the card reader to work. I was struggling with it just now, but hopefully I can get it to work. And we do charge a small fee to recover some of our processing charges when we use plastic. Or you can opt to purchase tickets by sending an e-transfer to treasurer@ottawa.rac.ca. And just make sure you send me an email as well at vice-president@ottawa.rac.ca to let me know that you've purchased a ticket so that I can keep track of it. So we want to keep the dinner as accessible as possible to everyone. So the $65 price we're charging for entry is partially subsidized by the club's funds. So if you're able and willing to, consider making a donation to the club to support our efforts, both in the dinner and in all of our other endeavors. Thank you, and I hope many of you here will come to the dinner. Thanks, Mick.
Thanks as always, Oscar. Also coming your way soon are the 2025 RASC calendars. Orders are being accepted online at the moment. You have the address there? Yeah, sorry, there should be a Google address as well. I don't see it. Forms.gle, there we go. Sorry, under the secretary there. So as usual, $16 for members, $15 if you buy more than one. non-members $20 apiece. Good value for money and a lot of familiar names, hopefully, in next year's calendar. Ottawa members in the news, a bunch of us, well, them, Dave, Taras, Honey, Brian Carroll, Katie, Mark Lilienthal, all cop mentions in the West Carlton online in their coverage of the CARP Star Party last month. And so I believe there's some follow-up material perhaps in the work as well regarding FLO. So that's all good PR. Thank you to all those that put their names out there. You're up, David.
Okay, I'm not Stephen Nourse. I'm Dave Chisholm, the president. Stephen is out of town, so I'm going to be covering for him here this evening. The council will nominate at least one person for each elected position, but please help us. If there's something that really interests you, please reach out to secretary@ottawa.rasc.ca if you're interested in any of these positions. They can be submitted by any member. Nominees must be members in good standing and 18 plus years old in order to serve as a councillor. And there's the email for Chris to send in your nominations. So here are the elected positions. So even though Oscar is in as the president, if somebody wants to challenge him for that, I don't think Oscar would appreciate that, but it's not closed. Oscar's going, please. No, any of these positions here, except for the past president position, are all open for election. Okay. So right now we're looking for a vice president. The secretary position again is being filled by Chris Tarrant. We are looking for a new treasurer, and we have 3 positions for the councillor, and we're looking for a meeting. We used to call them a meeting chair. Now it's a meeting facilitator. It was getting too confusing on our bylaws. So this is Mick's position here. We're looking for somebody to fill that. And what's that? You get a free shirt. That's right. And I move into the past president position. And then appointed positions. Right now we have some openings in these, and there again, if you would like to be in one of these appointed positions, there's somebody in there, please reach out, and we will consider you. But in particular, we're looking for somebody to run the public star parties. Katie did an awesome job the last couple of years. It's time for somebody else to step up. And the other position that's open is hospitality. We used to have somebody serve coffee and tea and cookies at the end of the meeting and soft drinks at the end of the meeting. And we haven't been able to fill that position. So is that something that you'd like to do? That would be great. And since I'm up here, I may as well continue on. The Ottawa skies for October. So sorry you missed it. New moon was October the 2nd. And the full moon, which also happens to be a super moon, is on October the 17th. This is known by our Indigenous folks as the Hunter's Moon. It's also been known as the Travel Moon and the Blood Moon. This is the second of 3 supermoons for 2024. We have the Draconid's meteor shower, October 7th and 8th. And it's not a very big one, about 10 meteors per hour. The second quarter moon will ensure the dark skies in the early evening, so it might be a good time to see that. Best viewing will be in the early evening from a dark location away from city lights. We've got the Orionids meteor shower. This one's twice as busy as the previous one, 20 meteors per hour. This one peaks on October 21st and 22nd. And the waning gibbous moon will probably block out most of the fainter meteors this year. But if you're patient, you should be able to catch a few good ones after midnight from a dark location. And then we have Comet A3. And this is a bit of an eye chart here. But basically, in the evening skies, I would say after the, about the 16th, 17th of the month. We should be able to see it. Rumor has it that it could be visible with the naked eye. And that's if it survives its trip around the sun. And if you miss this, you got to wait another 80,000 years. So maybe this would be a good time to look up in the sky. I've got I'm doing an outreach with the Scout group on the 24th out near the Mill of Contell, and I'm hoping it'll be visible that night. That would be awesome if they could see that. Sunrise and set times, as you can see, the days are getting shorter. Mercury is not visible, rising and setting with the sun. Venus is visible after sunset, starting in the mid-month. Mars is visible in the late evening and through the night, throughout the month. Jupiter is visible in the evening and through the night. So as by the end of the month, it'll be rising by 8 o'clock. Saturn's visible in the evening sky right now. Uranus is visible in the evening and Neptune is visible through the night. And there is our cartoon of the month. Ursa Minor. There you go. Bad pun.
Very good, David. Thank you, as always. Alrighty, and so with no further ado, our honoured guest speaker, Dr. Cassandra Marion from here at Chasm. Last time Kaz spoke with us was exactly 3 years ago, October 2021, talking about training astronauts up in northern Quebec. And which crater was it? Labrador. Okay. And so very happy to welcome her back tonight, and please give her a round on the way up.
Thank you.
Okay, you don't need this, but it's
Nope.
there in case of emergency.
Thanks. All right. Hi, everyone. Just give me 2 seconds because don't tell me. All right. It looks like my computer turned off in the waiting period. So just give me a moment. Oh, don't start. What? Oh, okay. It looks like it's going to come back to life. So while this is running, I'm the science advisor here, but most of my education and research is, I'm a planetary geologist. So usually I'm collecting rocks in the Arctic, sometimes with astronauts, but mostly not. And today I'm not going to talk about any of that. We're going to talk about monitoring climate change from space. And the reason is today marks the first day of Space Week, International Space Week, and the museum was putting on a series of activities. And so this was one that RASC so kindly allowed us to offer. Okay, it looks like that's up. I'm just going to rejoin the Zoom. Sorry about this. 2 seconds. Now, no video. Join. The reason I'm operating from my own computer is that part of this is workshop, and nope, I don't want that. Continue. There we go. And so at the end of the presentation, I'd like you all to think now what specific times and places and what things that you might actually want to go and see and track through time related to climate change. So where, if you had the power to operate satellites to go and look at something through time, where would you go? Because at the end, I have direct access to basically a satellite database where we can do just that. All right. And now I'm just going to share my screen. We're back up and running. Yay. Give it a sec. That one's yours. And I'm going to time this so that I don't go too long. We're in business. Woohoo! All right. I'm a mover, so I'm not going to stay behind the podium too much. Can you still see me on the camera if I just stay in this area? Thanks. I probably knock everything off the podium too, because hands. All right, so we're going to basically turn you all into remote sensing scientists. you're all going to learn how to interpret images from space. And we're going to start by defining Earth observation. So essentially, Earth observation is observing Earth from space. And I like to start off with this, the blue marble. I hope everyone is familiar with this image. This is the very first single image of the entire planet that was ever taken. It was taken by an Apollo astronaut partway to the moon in Apollo 17, 1972. And that's when the Earth became known as the blue marble. You may have heard of the overview effect. So many an astronaut will come back home having sort of a new perspective on our planet, having seen it from this point of view, particularly those that went to the moon, because you can't actually see the entire Earth in one view when you're in low Earth orbit. But all of the ISS and astronauts as well, of course. It's just not as far back a view. But looking at the Earth from this perspective, it can change you because you see how really small our planet is against the black of space, how fragile it is, how precious our environment is, especially when you see how thin the atmosphere is, you know, like the apple peel to an entire apple is keeping everything living alive. The other thing is when you see Earth from this perspective, we don't see borders. There's no lines between countries or cultures or religions or colors of skin, etc. It's just one planet, one home to all living things. And that moves you. And so most astronauts come back home and they tend to have more advocacy for the environment and other things as well. One way we do Earth observation is, you know, if you were going to take a picture, you wanted to take pictures from space, you literally hand an astronaut a camera and you send them to space. So this is considered Earth observation. This is the Canadian astronaut David Saint-Jacques. He was on the ISS in 2018, 2019. And this is him taking some beautiful photos through the cupola, which is a very famous window, which is also modeled in one of our exhibits. This is actually one of the, as much as it provides the best view from the ISS, when you're trying to take a photo of like really bright Earth and then like dark background, it's actually a lot easier to take good photos from some of the smaller windows and like cover them up really good. You guys probably know more about images, well, astrophotography, we'll call it, or it's astronaut photography. Anyways, if you took an image like this from this perspective, you might get something along the lines of this one. This one wasn't taken from David, it was taken from Chris Hadfield as he commanded the ISS in 2013. But this is the type of view you would get from the cupola. Now, in looking at this image, do you recognize anything on the surface of the Earth? Yeah. All right, so Great Lakes, exactly. One thing you'll notice is that north is not up. When you're looking at satellite images, they could be any orientation, particularly if you're looking at different data sets from different satellites. So that's one thing that's a little bit different. The other thing is there's no scale normally. In this case, we actually do have a little bit of help. Does anyone recognize what those are? Yep, Soyuz capsules. So you've got 2 Russian Soyuz capsules. One of them brought Chris Hadfield up to the station and back home safely. Though nowadays our Canadian and American astronauts usually take a SpaceX Dragon capsule up. The other things you'll notice is this image was taken in winter. So you'll see there's lots of snow on the ground. Some of this is cloud, you know, clouds over the Lake Ontario or Lake Erie there. You can see James Bay up here is frozen over, or partly anyways. All right. I think that's about it for that one. So essentially, we've got Earth observation directly in the hands of a human, or you've got Earth observation using instruments on a satellite being a moon or a planet or a machine-made thing that is orbiting a planet. I know I'm kind of preaching to the crowd here, but of course, our moon is considered a satellite as well as all the other moons in the solar system. And our technology has advanced so much that we can create instruments that can see beyond what our eyes see, beyond just visible light, but we can get so much more information by looking at the Earth in different wavelengths, not just what our eyes can see, our own built-in light detectors, but we basically when we're doing Earth observation, it's almost entirely using some form of light detection. And that's in this range, whether it's visible, near infrared, infrared, microwave, or radio waves. So most of the instruments, most of the data and images that we're going to see today, they're in the visible light, because I'm going to keep it very simple. But I will show a couple of examples of ways in which it's hugely advantageous to look at images, to collect images in other wavelengths. Even if you're looking in false color, you can get so much more information out of them, depending on what your goal is. So just a little poll of the crowd, and this is the cheat sheet. What are the kinds of things you immediately think of for monitoring climate change from space? You can just yell it out and I'll repeat. Anything? What's that?
Sea level rise.
Sea level rise, exactly. Yep, we can definitely monitor sea level rise from space in a variety of ways. I'll have one example of that, I think. Forest fires. Forest fires are huge in Canada. I'm not sure if anyone knows, but you know, space is constantly giving us information and updated situational information for forest fires, and giving, you know, authorities evidence-based direct images from space constantly to inform their decisions on, you know, where to send those firefighters or where to address the help, or just monitoring the fire in general. So that's a great example. All right, so we're going to look through some examples. There's a lot of these that I'm not going to show, and this is by no means a thorough list, but it's just to give you some ideas of the things in case I don't get to them. Most of the data, I'd say 98% of the data or the images we're going to look at today all come from a constellation called PlanetScope, which is from the company Planet. And they have a series of different satellites in orbit right now. One of them is SkySat. These are their bigger satellites that get tasked and more expensive. And then they have their PlanetScope constellation are these little doves. They're cube satellites. I could hold one in a single hand. It's about the size of a loaf of bread or a box of Kleenex, but you can launch dozens at a time. And if you put them in orbit, in the same orbit, and they're in a polar orbit at about 98 degrees, and they're orbiting one in a single line, one after the other, one after the other. And as the Earth naturally rotates, it takes a photo, or they take a photo collectively of every area of landmass on the Earth every single day, and then store it in a very easily searchable database, which is what we have access to today. Can't access it from home. I have a partnership with Planet that is allowing me to deliver this to you today. So what we're going to do is look for change through time, and that is what climate monitoring, especially from space, is all about. So we're going to compare images from, let's say, today to yesterday, today to last week, today to last month, today to 5 years ago of a certain event or thing. So you can know what you're looking for, or you can just cruise and find something new. This is more teaching you how to look at these images. So the thing, if we're not only looking in visible light, sometimes colors are not the colors you expect them to be, even in visible light. And sometimes you're looking at a false color image if you have an image that's, let's say, in the infrared or is from like radar. So just for fun, I'd like you to look at this image on the left, look at the colors, look at the shapes, and determine what it is you are looking at. These are both images from somewhere on the surface of the Earth. Does anyone know what this image is on the left? Can you identify what we're looking at? Yes, farmers' fields and irrigation, but you'd be surprised. Exactly, center pivot irrigation, but not everyone knows what that is or has seen round fields. So as soon as they see circles, they don't think fields. And for those who don't know center pivot, it's basically there's a post in the center of the field with a big arm, and it's watering in a circle, and so the plants grow in a circle. So exactly that. And then, you know, some of it's green, but some of it's not. And that's because some of it's either been harvested or different crops are different colors. All right. So on the right side, this one's a tricky one. What are you looking at? This gets everybody because it's kind of weird looking. And you can also tell me, yell out what you think it looks like. Maybe not identify it, but what pattern does that look like? Dendritic, exactly. That is the scientific official term, is dendritic. Does anyone know anything that has a dendritic? It is a system of rivers, but they're not frozen. So the dendritic is like tree branches. That's where the word comes from. But often I get tree roots from kids. They're like, they're tree roots, but you can't actually see tree roots typically from space. But these are rivers. This is a lake. Okay, this is in true color. Why is that liquid water? It is not frozen over. Why is it gray and white? Yep. There's two things. One is angle of the sun and cloud cover. It's reflecting the clouds because the sun is low on the horizon. So it's a good crowd. You guys have the answers real nice, really good. Wow, I'm gonna have to work harder next time. All right, so yeah, exactly. You're getting it's fairly it's basically mirroring the sky. These are river systems. All this dark stuff down here, is actually a mountain chain. And these are all the tributaries that are flowing down the mountain into the lake. And on the other side here is desert. So it's actually a very dry area. This never freezes over.
So
That's Egypt. Yeah. All right. This is somewhere in the States. Can't remember exactly where. Okay. All right, next test or training. This is fun, right? All right, so looking at these 4 images, one image represents each season. So we've got winter, spring, it's early spring tip, summer and fall. And I'd like you to try and figure out which one is fall. Really, you'd have to identify all of them to determine which one is fall. But things to think about. This is the Green River in Utah, so it's in a desert region. Look at how much vegetation there is. Look at the water level, the color of the water. How much vegetation is around the river versus maybe elsewhere. Ooh, see, they're not all the same answer. I'll give you a second. So everyone, which one is winter? Yep. Okay, so A, because it's white, it's covered in snow. Yes, it does snow in Utah in some areas. All right, so that's one down. All right, who thinks it's C? Okay, I've got maybe 1, 2, 3, 4, 5, 6, 7, 8 hands. Who thinks it's B? Ooh, about the same. And D? All right, so we've got there's like a camps in every one. So I'm going to tell you the answer. It's B. B is fall, but I'll explain the why. So we've got early spring here. So it goes winter, spring, summer, fall. Early spring here, you can see the water level is very high. It's very muddy. So that there's a lot of sediment in suspension. And so you can't actually see through the water. You're seeing the sediment that is in suspension. But you'll also see that there's not much vegetation around because spring blooms haven't occurred yet, which is why I said early spring. Summer, you've got lots of vegetation. The water's still fairly high, pretty murky, but you've got some green around the river. And so you've got the most vegetation is typically midsummer. And then we've got fall. So you've got a little less vegetation, but there's still some there. But the main giveaway is actually the level and the color of the water. So you can actually see there's sandbars at different places in the water. And typically in the winter, when all this snow melts, all that water goes into our tributaries and our lakes and our rivers and eventually out to the oceans. And so that's when our water levels are highest, and then they go down during the summer and then down again in the fall, generally. And so the water here is green because as the water level goes down, the intensity of the current, basically the power or the speed of the current is strongly reduced. And so it has less power to put those bigger particles in suspension. And so you're basically seeing through to the clay bottom, and that's why it looks green versus the yucky brown where it's all turbulent and mushy. Okay, last one, and then we'll go through some fun examples. Okay. What is shown in this image? Is it an alien with a metal detector? Anybody think it's that one? Hey, anybody? No takers. All right, there's not enough kids in the room, that's why. Water treatment facility or a diamond mine? Ooh. Okay, everyone thinks it's C? Anybody B? I got like a sheepish maybe. Okay. Well, the majority rules. So it is a diamond mine. This is the Diavik diamond mine in Northwest Territories. And you can see, but it's tricky because the sun angle, these are giant open pit mines, but part of it, like a large part of it, is in shadow because the sun is sort of aiming this way, right? So you can only see one side. So those actually can be mistaken for body of water. Okay, and you're getting a round feature, which are also round. You got round open pit mines, but you also have round features in a water treatment plant. You know, there's roads, there's an airstrip because it's quite remote. The other thing you'll notice is it's on a big lake, and you can see some sediment moving in the lake here, but you can't hear. And this, it's hard to tell on this angle, but it is a very deep blue, not black. And so this is deeper water than this generally. Okay, so just things to think about as you're looking at these images. All right, so now we're going to run through a couple examples, and I'm going to check on where my time is at. Cool. These are images of the Milne ice sheet on Ellesmere Island, in the northern part of Ellesmere Island. It's one of the very last remaining ice sheets in Arctic Canada. And these two photos were taken 5 days apart. You'll notice the dates are July 2020, very early on in the pandemic. And unfortunately for the researchers, well, unfortunately just in general, this thing broke and lost 40% of its ice. That's 80 square kilometers of ice in one of our last remaining ice shelves, lost to the ocean in a day. Now, over time, that ice melted. That didn't take a day, and we were tracking the icebergs and as it broke down. And so it is now, you know, all added. And overall, if that ice then, you know, 80 square kilometers of ice melts in the ocean, what happens to sea level? It rises, right? Locally, it actually goes down temporarily, and then, but globally, rises. But this happened early pandemic. And I can tell you as an Arctic scientist that in the year 2020 and 2021, almost no scientists were allowed north. And I was in the Arctic in 2022 and 2023. And so the scientists that actually study this ice shelf, a broad range of scientists, not just ice scientists and climate scientists, but there were, you know, specific expertise in biology. There were ecosystems in lakes that were thousands of years old that were on this ice shelf that is just destroyed in a day. Entire unique bacterial ecosystems, things like that. So it wasn't just the ice that was lost. But this is a shocking thing, but it's meant to show you that we couldn't get up there. And so some of the only information that we had, the only way we could document this crazy broken ice shelf and the impact it's going to have on us was through imagery from space. There was some content we could get from aircraft, but there wasn't a lot of aircraft flying at that time either. So those poor scientists, they had to wait 2 years to go up and document the damage. So we talked about ice, monitoring our water. Now, I'm not just talking about ocean and sea level, but all things. So this is 2 examples of our Great Lakes. On the right side here, this is Lake Erie. And early in the spring, particularly just after the snow melts, there's huge sediment plumes. The sediment is moving so much so, and it's so close to the surface that we can see it from space. So you can see these beautiful sediment plumes. If you compare this day to day, the texture and the pattern changes. Here on the left side, I've got, this is part of Lake Huron, and it's showing you ice melt in the winter there. And we've been monitoring the Great Lakes and how much ice forms every winter, and it has been in decline since 1973. All right, so now we're looking at more water, but in the case of flooding, which also tends to occur when your climate is changing. This is the Red River Valley in Manitoba. This is the small town of Morris, Manitoba. On the left side, you have a true color image, okay? The light that your eyes see, but it's like mostly brown. And so trying to determine, normally there's a river, it's this tiny pencil line that squiggles in and out around here across the town. The water is actually way out to here. It's entirely covering the town, but you can't very easily distinguish between the water and the fields because they're both brown. But if we look at different wavelengths of light, we combine them, we use a software to combine different wavelengths of light to pull out the information that we want. In this case, it's red and green wavelengths, drop the blue and add near infrared. We can assign colors that way. And in that case, water is a false color, but comes out as turquoise, and vegetation shows as a pinkish red. And then they're very easily distinguishable, and you can monitor the extent of that flooding a lot easier. On the opposite end, you also get droughts when you get climate change. Has anyone been to Las Vegas? Drank the water there? That water came from Lake Mead, which is the reservoir that supplies all the drinking water for the city of Las Vegas, and it is fed by the Colorado River. The Colorado River is dwindling more and more. Once upon a time, it reached the ocean. It no longer does. And Lake Mead, in about a year's time, just a couple of years ago, the reservoir water level went down 6.5 meters in a year. Now, it does have its natural seasonal fluctuations. It does normally like higher and then lower, just like our river systems. But that was one of the more drastic changes. And overall, on average, it has been going down and going down. And I'll tell you that folks in that region, they're going to be in trouble if they don't conserve and change their ways a little bit more. But some of it, some of it is overuse, and some of it is just the influx of water is diminishing, right? All right, so I'm going to switch gears now. We're going to talk about deforestation. Mick and I were chatting about this a little earlier. This is an example from Bolivia. Even though shocking, clear cutting is still happening. But that's not the only thing. This is an example of clear cutting. They clear cut 2,000 hectares of trees to put in new sugarcane fields and factory processing plant. They're doing that for sugarcane and soybeans quite often in Bolivia and Brazil these days. So this is the before and after. I think there's 6 months between these two photos. And this is from 2016 and early 2017. So it's not that long ago. The other things we can do, it's not just clear cutting, but we can monitor tree canopies. We can measure the heights of trees, just general quantity of biomass. You can monitor that from space as well. But trees are hugely important for climate change. And if I had a group, normally I'm talking to, a group of 10-year-olds, and I ask them, what do trees do for us? And then they say, they make good air and they take out the bad air. But that's basically it, right? They're not only, intaking carbon dioxide and giving us nice oxygen to breathe, but they're also sequestering that carbon dioxide. They're basically keeping it in the wood. If you cut down all those trees, you are returning that carbon dioxide to the atmosphere. All right, this is an example of major coastal changes in Indonesia. So we've got two photos that are flipping. They're 20 years apart, but you can see a concrete example of sea level rise. So you can see right here, this is where the coastline was. And you can see there's lots of farmers' fields that used to be here. There was some buildings, some businesses, even sort of the downtown area. It gets completely covered up in a 20-year span of time. All of these people have lost their homes and their businesses. And you can see not only sea level rise, but you can see the direct consequence to our culture or, life. You're seeing migration as a result of it. And that's one of the lesser consequences, right? Forest fires. We were talking about this earlier too. So this is two examples. This one is from Australia in 2016. And also just before the pandemic hit, Australian fires were, they were going to be the big news item that year, and then that changed very drastically. But this is from 2016 fire. This one is from 2 summers ago now. This is Hay River. This is the Great Slave Lake Yellowknife just up here. So Hay River fires. I have another Alberta example. This is from this summer, from northern Alberta. But Canada's got a lot of fires. But I will tell you that we are in the midst. The Canadian Space Agency has just put funding towards building its own wildfire its own satellite solely dedicated to monitoring forest fires. And so we're going to have a direct government information system. So pretty cool there. I will also mention that if you're collecting data from space to monitor the forest fires and inform authorities, then you don't have to put any aircraft or pilots in danger by getting closer to the fire to more inform. You do that, obviously, if you're going to be dumping water on it, et cetera, or getting more localized information for assisting people that you can't see from space. But every time we're getting sort of the broad context view, you're putting a lot less people at risk. This is more of a positive side because I've done a lot of doom and gloom. But this is an example of the west coast of Grande-Terre, which is in New Caledonia, France. It's a French island, but it's actually really close to Australia and close to the Barrier Reef. These islands actually have, I think they're second to the Barrier Reef in size of coral reefs. But they have huge colonies of seagrass. And like trees on land, seagrass are basically another plant that can sequester carbon underwater, and they should be protected. And so these were identified. There's huge areas of seagrass that were identified here, and they are now protected and cannot be bulldozed to put in a nice resort and send that carbon, essentially cycle it back into the ocean, which would cycle it back into the atmosphere. So there's one positive, things that we can do when we are monitoring and we can take action with that information. Example of earthquake. This is not so much related to climate change, but just to give you an idea of sort of population and city changes that can also be monitored. So you've got a before and after. This is a 7.8, I think, magnitude earthquake that occurred in Turkey in 2023. Notice the stadium here. This looks like a normal stadium, but in the after the earthquake, you'll see that there's lots of white dots. Those are tents, shelters, where they've got all the survivors there, and they're basically hosting them, feeding them, giving them somewhere to stay. The other thing we can monitor are fishing routes, shipping routes. And so here we've got an example of a giant oil spill. It's just changing over time, but essentially this tanker ran up on the reef, tanker broke in half, and then spilled a bunch of oil. We can not only monitor the tanker and get anyone to safety, but you can monitor the oil to then send in the crew to address the cleanup. And then does anyone remember the Ever Given getting stolen? Because it also happened sort of in the pandemic, pretty slow days, and we were on the news constantly. This was like the event of the week, where it blocked the Suez Canal end to end, and 400 ships were waiting for a week to get through. And Planet was actually providing the day-to-day images of what was going on at that point. All right, so this is another example. Does anyone know what this is? Nope, not that one. This is a volcano. It's in Iceland, but it's called the Fagradalsfjall volcano. Anyone else can say that? Bonus points, because I had to practice. All right, so if you're looking at this in visible light, again, it's very difficult to distinguish when colors are very similar. If you're on sort of a barren landscape, you don't know what beige is to another brown to another green. Here it's clear that this is dark, so you can guess this is lava. You've got some smoke here and a couple little dots that you're probably like, that's probably molten. But if we look at the exact same image, but similar to the flood image, we look at it in only near infrared, a combination of near infrared, green and red wavelengths, then it actually pulls out not only what we already established, vegetation comes out as a pinky red. So this is actually all vegetation, which you would never have guessed by looking at this image. But anything that is hotter is going to show a higher intensity, right? And so they've pulled out, now we can see entirely where that lava is molten, where we definitely don't want to send the robot or a person to walk in too close to. Yeah. Okay. Ooh. Oh, I like this one. Okay, this is going to be the last example until I play this. My beeper went off. Okay. So last example, this is in the States, and I can't remember which state now, but there's a before and after. So this is before, and this is after. Any guesses as to what that is? Yeah, the path, it's the destruction path of a tornado seen from space. Tricky to see the tornado itself because you'd mostly just see the clouds. And then if you had radar, you'd still just see the surface. You wouldn't actually see the storm. Well, depending on your radar. But now the post-storm, you can see the actual path that it took. All right, I'm going to stop there and I'm going to flip to another screen. So did anyone come up with any ideas of where they might want to see? There we go. Oh, you know what? I have to share my other screen now. There we go. Let's do this one. So I'm going to flip. Okay. So I have an example first. I'm going to zoom out. So just to show you what this software is capable of doing. So this is an island in the Canaries, in the Canary Islands. If I zoom out, it's just off the coast of Africa, but it's a Spanish island. You can go take a holiday there. All right, I've also trained some astronauts there, done some analog missions. I haven't, but someone else. All right, so what we can do, and I might have to refresh because it's going to get mad that it's been offline for a little bit. So I'm just going to do a whoop, a refresh. All right, and it hopefully will just repopulate that. Sweet. Okay, so in 2021, there was this, an unexpected, or sort of, they had a little bit of warning, but not a lot of warning. There were a series of eruptions. These are volcanic islands, so it's not like it was a big shock. People build their houses on the volcanoes all the time. Pretty much anywhere on the island, you're on a volcano. But if you look closely, so I zoomed into a particular section here, and I've chosen my data. I'm gonna have to, won't be able to put me. There we go. So this is sort of the topographic high, the mountains here, and there's a few little spouts, but you can see this area here, and you can see it throughout. This is city, basically. These are all towns. Every little dot in here, those are houses. Okay, so this is before the volcanic eruption, September 8th, and then the actual volcanic eruption occurred. Do I have the other data set? Yes, I do. Through a series. I'm going to switch it to here. If I move this here, now you've got a giant cloud, so you can see the eruption in phases. Okay, everyone see this billowing smoke? It's really difficult to make out the lava here, but I'm going to show you what it looks like today after that eruption. So I'm hoping you can make that out from there. Oh, let's try. That's really dark. But what you can tell is anywhere that there's black, there are no longer houses. They are entirely covered by lava flow. Okay, but with this software now, I can go before, after, before, after. Okay, so just to give you an idea of what you can do. I've got lots of other examples, but if somebody has somewhere that you want me to go and look at, we can do that.
We see like some aftermath of Hurricane Helene.
Ooh, so a tricky thing we can go and see, do you have a specific area that you know that you'd be able to see something from space? So resolution wise, I could probably see, zoom in enough to see like the dots of the houses in your neighborhood, but I won't be able to make out what kind of car you got.
How about Tallahassee, Florida?
Tallahassee, Florida? Okay, let's try. Now this upper bar here is like in my way for managing this. You don't see that, do you? No, you don't. Interesting. It's the zoom bar that's in my way, so just ignore that for a minute. Okay, Tallahassee. No, I'm gonna go here. Actually, Tallahassee, Florida. Am I spelling that right? There we go. We're gonna get out of compare. I went quite a ways inland, eh? All right, so now we've got data from today. This is a photo taken of Tallahassee today, but you can see it's a little bit cloudy because again, visible light, so the clouds get in our way. We want to go find an image that doesn't have clouds. So you're seeing my range of selection. It looks like they had lots of cloudy days recently. Okay, I'm gonna undo this one because it ends up stacking. Oh, there we go. There's a nice day. But wait, Helene finished when? When was it? I don't remember the dates. Not that long ago. This might be pre-Helene. Or in the middle of it. Actually, it's probably all those cloudy days I scrolled over were. No, actually looks like I should just see whiteout from, but there should be several days of it. It's not that far back. 26, 27. All right, and this is the 23rd. Okay, so this is before. All right, let's try. We'll put in a before. And 27. Just because there's a few clouds doesn't mean we can't zoom in and see something else. Is there any? Ooh, here we go. Looks like there's a little lake here. Okay. Definitely it looks like there's a lot more sediment stirred up in there on this lake. What else could we see? We might have like a ball diamond that's flooded, something like that. You might be surprised though that when you do have hurricane go through the flooding, the water levels do go down quite quickly, like less than a week sometimes. So it's kind of tricky to see unless you know what you're looking for. Like if you're like, this happened in this neighborhood, then we can go check it out. So I'm trying to look for little water bodies or coasts or it's usually stuck by there. Anywho. Someone over there was asking for something. Beth, yes, that we can do. Jasper fires. So Jasper, Alabama, what? Didn't know that existed. Oh, wait, sorry. Here I am cursing Alabama. Okay. No, stop. All right. Supposed to pretend I did that on purpose, right? Alabama, no, I don't want Alabama. This is your meeting's really late. This is why. I'm like, haven't had my evening coffee. Yep. Okay, I think we got it. All right, so now I know where I put my box because I've already found this one. So you're going to be shocked by actually the amount of forest that is now absent. So if I do right after, just a moment, I'm actually going to go a little bit further back in time. So if we go 2024, and if you need to kick me off after this example, that's totally cool. Okay, I'm gonna go.
No, if you're on time for Q&A.
Yeah, no. And there's 24, 08. Let's do 22. Okay. I can't remember when the fire started, but it was fairly early in the season. Okay, this should go all the way back down there. If anyone can tell me when those fires started. Oh, here we go. Mid-July. Okay, so this one, not burned yet. Oh, that'd be good. Okay, this is going to be a good example one. Let's put you there. So we got July 17. Okay, you can actually see some of the smoke. July 18, we got some smoke happening. Oh, let's see, what's that one? Yep. Down there. Now what I'm going to show is just not during the fire, but now before and after. And this is kind of scary. All right, so the town of Jasper is just up here. And this is just the valley down. So I'll show you the background. It's hard to see in the coloring of the projector here, but all of that black is green forest. And now there's nothing left of this whole area. And it's actually burned all the way down that valley, quite a ways. And if we zoom into the town itself, you'll see that it does get blurry as I get a certain distance. But even if you're looking at the trees just around the town, and you can see that there are many a building here that this is the side that mostly got damage. Zoom out. Yep. Pretty crazy. Before after. Did you want me to do one more, or are we Q&A? Cutting me off. Do you have a big hook? Do you have a big hook? All right. Sounds good. I'm gonna stop sharing here before. Yeah, any questions?
Chris, do we have any online? No. No questions online. Anyone in the audience, please? There's no. Was, anyone?
How far back was that contract? How far back can you go?
So they started being launched in the early, I think maybe the first ones were 2014, 2013, 2014. Usually if I'm trying to find complete data sets, test. If I'm looking for complete data sets, I usually don't go much farther back than 2018, but that still gives me 5-6 years of comparison with this data set. I mean, we have many other satellites that have been up there a lot longer that you can use. This is one of many. You know, there are thousands of Earth observation satellites up there doing different types of jobs. There are thousands more that are other types of satellites, GPS, comms, and things like that.
I was quite interested in the radar images, the synthetic aperture radar. Does Canada have one of those still?
Yes, we do. We have currently 4 in orbit, and there's money already guaranteed to build another one. So we currently, RadarSat-1 has been retired, but RadarSat-2 is still operational, and RadarSat Constellation, which is 3 newer RadarSats that were launched in 2019 that work in concert. They're in orbit right now doing some really good stuff. Yep. And Canada is known for its expertise in synthetic aperture radar.
Thanks. Anyone else, please? Alrighty, if not.
Yeah. Thanks, guys. You have your break. You have a break now, so I can
Yep.
get rid of this. Okay.
Alrighty. So. Check. Usual thing, museums closed, facilities are around the corner back there. Trivia question, quickie. Recent bit of news, one of the closest stars to Earth has recently been confirmed to have a terrestrial-like planet, i.e. not a gas giant. Anyone know which star I'm referring to? And second bonus points question, what else is singular about that particular star? So can we try and keep it to 5 minutes, please? Alrighty. Trivia question, new terrestrial planet, which nearest star, and what else was cool about it? Any answers? Wrong. And highest proper motion in the sky. Very good. Okay, so you get the holiday in Tahiti. Alrighty, Simon, you're up. All right, here we go. All right, you knew you were coming up. Why did you sit all the way back in there? Oh, you know. Yeah. Okay, so there's your go button.
Okay. I got a go button. Okay.
The laser on that is not working. If you need to point, that's it.
What have I got to point with?
Point.
Oh, I see. I've got to point with that. All righty. Boy, life's getting complicated.
Okay, there.
Okay, let's see. It's all black. Oh, I got you. So there we go. I got a laser. Okay. I'm just going to get a little light here. Oh, I'll do it this way. There we go. All righty. We're up and running. Oh, how long do I have?
20, 25.
Gotcha. Yeah, I know. Okay. You know, apparently, humankind is on its way to Mars, or at least that's the message that NASA and a billionaire or two is pumping up in the media. their mission referred to by the NASA communications is called Artemis, and it's named for the twin sister of the Greek god Apollo. And just in case you didn't get the point, that's a reference to the Apollo program of the 1960s when NASA put men on the moon, and that today we're trying to be more inclusive, thank goodness. Let me see if I can pass my last. Holding on. There we go. That's much better. All righty. So dueling. Which one of these do I press? The big green one. It works. Okay, we're in business. All right, to put it simply, the idea behind Artemis is to build a permanent logistical and science platform located at the south pole of the moon, from which to springboard a program to get humans to Mars and back, maybe. Now, why go to the moon before going to, well, if you're Elon Musk, why go to the moon before going to Mars? Well, because gravity is only 1/6 of that of the Earth, and so lifting materials up into space is easier. Why the South Pole? Because water ice has been identified in permanently shadowed craters, and because you have a 360-degree unobstructed horizon for scientific observations and measurements of the solar system. Now, while NASA and its potential astronauts are really pumped up about Artemis, it's not going to be plain sailing. There are major uncertainties that have already cropped up, and I'll just mention two here. Number one, the funding. NASA is over budget, which is a polite way of saying that it's broke or very soon will be. Although part of the issue stems from the time and cost overruns of the Webb Space Telescope, this applies especially to NASA's Solar System Exploration Program. You're probably aware that the joint NASA European Space Agency sample return mission is currently being reconsidered. Even though most of the samples have already been drilled and deposited on Mars by the Perseverance rover. Whoops, that's not what I'm looking for. There we go. All ready for pickup by a second rover that will cost a further unbudgeted $10 billion US that neither agency can afford. And perhaps you've also heard of NASA's Veritas mission to place an orbiting platform around Venus to remap the planet's surface sometime during the coming decade. Well, it hasn't exactly been cancelled. That's budget problems again. But last year it was put on hold, although it appears to be back on again this year. But don't hold your breath on that one. Now, major uncertainty too is the lunar water that everyone's getting excited about. I'm sure you all know that the moon is a dusty place. We've known this ever since Apollo, hence the footprint picture. We've also known for at least 60 years that the lunar dust is very abrasive. It's not surprising. 4.5 billion years of asteroid and meteor bombardment have ground the lunar rocks to a very fine powder. And these rocks are made of silicate minerals. So the dust is essentially made of tiny nano shards of the mineral plagioclase feldspar that slice and dice anything that they come into contact with, including spacesuits, but more especially the gaskets, rubber or silicone, on water purification devices. Now, this means that not only could there be an issue with purifying the large quantities of water necessary for drinking, it's not even clear how to get all of the dust out of the water, which potentially poses major issues if you want to use it as rocket fuel. Remember, there are gaskets in rockets too. And in the meantime, while NASA tries to sort itself out, there are individual scientists who are getting on with their allotted task of studying the moon and informing us of their results. Now, there's a lot of scientific endeavor actively underway in the field of lunar science right now. To be sure, some of it is driven by the prospect of the Artemis program. The potential for funding is always a draw, but why not? Now, what's remarkable, however, and this is my personal view, and I always emphasize this, is how much of the lunar science being undertaken today harks back to questions that were first asked years ago. Some of the science is a bit esoteric for a general audience, so again, in my personal view, I've selected a short list of topics that catch my geological eye and that I think would be of interest to amateur astronomers such as ourselves. That's you included. So let's start with that age-old question, pun intended, just how old is the moon and how do we know? Yep, we're still asking that question in 2024, and there's a reason for it: contradictions. It turns out that when you look at the history of the planetary orbits at the scale of the solar system, you arrive at a different age for the moon than when you study the surface of the moon itself. So how does this work? The consensus on moon formation, I'm sure many of you know this, is that it occurred by the collision of a Mars-sized planet called Theia with a proto-Earth about 4.5 billion years ago. Now, this means that Theia's orbit was unstable, most probably because of the migration antics of Jupiter, initially migrating towards and then away from the sun, sometime during the first 100 million years of solar system existence. Now, in this scenario, the moon first formed with a magma ocean, some hundreds of kilometers deep, maybe more than 1,000 kilometers. Maybe the entire moon was molten, according to some, but would have crystallized to a solid rock, from a magma ocean to a solid rock, in about 10 million years. Remember that number, 10 million. 10 million years, of course, after the collision. However, when the moon rocks collected from the surface by the Apollo program were analyzed, they were analyzing uranium lead in zircon crystals, the magma ocean appears to have solidified about 210 million years after the solar system formation started. Now, that would mean that if a magma ocean crystallizes in only 10 million years, the collision must have occurred at about 200 million years instead of much less than 100 million years, and that's a big discrepancy. Well, early in 2024, early this year, planetary scientists published a solution to this apparent paradox. After confirming independently that the moon did indeed form at about 50 million years after the solar system formation, they described a way to prolong the life of the magma ocean of the moon. Yes, the lunar magma ocean cooled and crystallized in about 10 million years after the impact at about 50 million years, but it heated up again, remelted, and then cooled down all over again by about 200 million years. It's a neat story. How does it work? Well, the initial orbit of the newborn moon was highly elliptical, probably, as opposed to being nearly circular, which means that the Earth's gravity affected the moon differently in different parts of its orbit, when it was closer to the Earth or when it was further away from the Earth. And this puts a periodic squeeze and relaxation effect on the moon that generated energy that turned into heat, and hence a new lunar magma ocean formed. So assuming that it took 150 million, that's an assumption, assuming that it took 150 million years for the lunar orbit to circularize, this would explain all of the available evidence and solve the apparent paradox. After all, 50 plus 150 gets you to 200. However, there's always a however. It's a neat story, but however, this is actually a confirmation, which is great in and of itself, a confirmation of a story that I'd already told you about 2 years ago, as you can see in this slide from my 2022 RASC talk. Let's move on. This will become a recurring theme. In 2024, a headline read something along the lines of, "The moon turned itself inside out." Well, I just had to read this one. We've known ever since Apollo that there are titanium-rich lavas, rich in the dense or heavy mineral ilmenite, that we can see on the lunar near side. We can detect it at least, can't see it visually. Note in this particular image here, note the blue in the middle image. That's this, or that's purple on this slide here. And that's ilmenite, that's its formula, iron titanium oxide. Put this where I can find it again. On the right-hand side of this image is a representation of certain aspects of the lunar gravity field. We don't need to get into technical details here, but you can see what look like blue veins. These things here, they're pretty obvious. Those blue veins are all over the place, and they're covered. In other words, they're covered by, rather, In other words, they're older than the lunar mare. So here, lunar mare here and lunar mare there, and they're covering this big vein type feature here. So the veins are older than the lunar mare. Whoops, I didn't want to lose that. There we go. Very good. Okay, now the story here is fascinating. The idea is that these veins appear to be ilmenite-rich rock, which forms thick vertical sheets. They're called megadikes within the lunar mantle beneath the lunar crust. The dense ilmenite is thought to be the dregs left over from the crystallization of the lunar magma ocean that we just discussed. So they must date to somewhere in the first 200 million years of the solar system history, as we've just seen. Now, because the ilmenite-rich rocks are dense, the idea is that they would have sunk through the much less dense anorthosite crust, that's the white crust that you're all familiar with, apparently sinking at least in part as veins, these megadikes, and then ponding at depth within the lunar mantle. So here's the idea. There's one of these blue veins, and that the ilmenite-rich dense materials sinking down into the mantle and then ponding down there. Okay. Okay, but why are the ilmenite-rich lavas that we see today concentrated on the lunar near side? Surely the ilmenite-rich megadikes formed all over the moon. Well, there's the very old, absolutely gigantic South Pole Aitken impact basin on the lunar far side that some suggest really messed with the mantle of the early moon, forcing the ilmenite-rich mantle to migrate to the other side, the antipode of the moon, on the lunar near side, just below what would eventually become the Mare Procellarum. Mare Procellarum here is there. P for Procellarum. There we go, right in the middle of all these ilmenite-rich lavas. I'm sure many of you already know where that is. So the lavas that form Procellarum would have been derived by the melting of the ilmenite-rich mantle, which was concentrated directly below what is now Procellarum. So ilmenite formed in the magma ocean that gave us the anorthosite crust of the moon, sank into the underlying mantle, was gathered and concentrated on the near side just below the lunar crust by a giant impact on the far side of the moon, then erupted onto the surface as the Mare Procellarum lavas. I guess you would say that the moon literally did turn itself inside out. It's an exciting and dynamic story. However, there's that however again. It's really yet another confirmation, which again is a great thing in itself, of a story I'd already told you about 11 years ago, as you can see from this slide from my 2013 RASC talk. This time, the confirmation in 2024 comes from the fact that the recent numerical, or rather comes from recent numerical modeling of how dense materials, the ilmenite, would sink as vertical sheets in the newly forming moon, which is more a reflection of the increasing power of computers today than of new observations or data. Another lunar story that keeps coming back is based on the idea that 4.5 billion years after its formation, the moon is still cooling and globally shrinking. I had trouble with this idea back in 2011 when I first talked to you about it. The idea is that if the moon is still cooling and therefore shrinking, then faults, in other words, fractures, and folds must be accommodating the shrinkage of the lunar surface. And studies since 2010 have been seeking to identify these faults and folds and attempting to link some of them, at least, to seismic shocks, moonquakes, that were recorded by the Apollo program instruments left on the moon. Now, how do they do this? Well, they look for recent impact craters that have been partially obscured by material associated with a scarp or a cliff or a steep slope. But here's the idea. There's a ridge here. It's a scarp. It's facing this way. And here with this single arrow, there's a crater. And it's been obscured, half of it, this half, has been obscured by this stuff here associated with the ridge. And the idea is that all of this stuff here moved that away on a gently dipping fault plane, which would have been dipping in this direction and came to the surface here. And that therefore obscured the crater. It's not that I have an issue with the idea of cooling and shrinking, though it does seem to be a bit of a stretch. That is a pun intended, after about 4.5 billion years. It's more that I have trouble accepting the observational evidence for the proposed faults and folds supposedly operating today on the moon. This is a slide from my 2011 RASC talk on exactly the same subject. As I said, this is not new. On the left, you can see how contraction, perhaps driven by global lunar shrinkage, but not necessarily, can generate a shallow dipping fault and a topographic hill or scarp. So here's your scarp, here's your shallow dipping fault. This is moving this way, this is relatively moving that way, and there you have this scarp. But on the right, you can produce exactly the same scarp by sliding material down a pre-existing slope of undefined age, maybe a little older, maybe much older, in what you call a landslide. So if you have a high ground here, and you've got your crater sitting out here, and material slides down in a landslide, and you end up with a scarp just over the end, it still can partially occlude a crater. Both scenarios can result in the same features, but the one on the right does not require shortening of the lunar surface or contraction of the moon, nor does it require that the slope down which the material flowed has to be young. So, take another look at this image from the 2024 paper and decide for yourselves which of the two scenarios might best apply. I'd suggest that maybe it's equivocal. Okay, so at this point, in order to help Mick, I have to skip over the next section. And that one. And there we go. Okay. It's been known since the analyses of Apollo samples performed in 2008 that the rocks of the moon are not bone dry. However, the samples concerned at the time were tiny glass beads that condensed rapidly, they chilled from magma that was thrown upwards as fire fountains. This is an illustration of, that's wrong, there we go. That's a fire fountain, that's a photograph taken for Earth. That likely occurred all over at least the near side of the moon during the time of the Mare basalt lavas, when they were being erupted about 2 to 3 billion years ago. So what's new 16 years later in 2024? Now, scientists have now found grains of the mineral apatite in a tiny meteorite that they determine comes from the moon. Said tiny. Notice the scale bar here. You might miss it if it actually fell on your house. The importance of apatite is that it is a complex calcium phosphate that contains OH, hydroxyl, which also means it's actually related to water. There's the formula for apatite, and there's the hydroxyl sitting on the end there. You see hydroxyl, you're thinking water. This really is dueling controllers. And if you think that that meteorite was small, just look at the size of the apatite grain in this image, which is also taken from the 2024 paper. That's the apatite grain inside that box. That's 900 microns. 1,000 microns is a millimeter. So we're getting a lot of information out of a very, very tiny piece of rock. The importance of the meteorite is that it is not a piece of Mare lava. No, it's a small piece of anorthosite, the white stuff that you see when you're looking at the moon. More importantly, it's a piece of Faroan anorthosite, which means that it formed by the crystallization of the moon's magma ocean. Here we go again. Not sure which one, because as we've just heard, there apparently were 2 of them. That means, though, that water in this sample was present during the first 200 million years of the solar system. And most importantly, it means that we now have, whoever is working on this, now have to include the potential chemical effects of water in the collision model for the very formation of the moon itself. And that may lead to some very interesting consequences. We'll have to wait and see how that pans out. In 1936, people discovered the muon, a heavier version of the electron. It was so unexpected that a well-known cosmologist famously declared, "Who ordered that?" Well, the same could be said for the Compton-Belkovich feature on the far side of the moon. And in case you're not aware of the Compton-Belkovich feature, it's parked back here. This is the near side of the moon. That's the far side. This is a map of heat flux. There's your Compton-Belkovich anomaly. And that's what it would look like if it was sort of projected into 3 dimensions. Now, according to a paper published in the summer of 2023, it's more or less round, as you can see, about 50 kilometers across. And according to the microwave oven, that was a slip, the microwave measurements, all right, it's getting tired here, has a heat flux 20 times that of the surrounding anorthosite highlands. That's enormous. Now, there are not too many ways to account for this. Given the size of the heat source and the magnitude of the heat flux anomaly, scientists suggest that it has to be due to granite. Not just a piece of granite that you might put in your pocket, but an entire intrusion or a big bubble of granite located just below the surface. Now, to a geologist, that sounds like the Canadian Shield or something either in the Appalachians in Newfoundland or New Brunswick or the Canadian Cordillera in BC. But what's it doing on the moon? The moon is not supposed to have granite. On Earth, the geological mantra is no water, no granite. So is this even more evidence of even more water involved in the history of the moon? But whatever, it's a case, yet another case of a relatively local feature potentially requiring that we take another look at how the moon formed and evolved globally. In other words, when you look, you never know what you're going to find. My last story concerns everyone in this room who has a telescope, even a relatively small one. Light-colored swirls of dust that are brighter than the background lavas. The largest and best known of these swirls is Rima Gamma in southern Mare Procellarum. Already showed you where that was. And it's visible to amateur astronomers, even through modest telescopes. The scale bar here on the Rima Gamma image, there, that scale bar there, there's Rima Gamma going all that way. That's about 100 kilometers. Other examples include Mare Ingenii, which is 350 kilometers across. That's here, it's there. And Fursov crater, which is about 50 kilometers across, but they're both on the far side. So for all the world, these swirls look like dust transported by windstorms. But of course, that won't work on the moon because there's no air. So scientists have tried to come up with models involving temporary winds generated by impacting comets, dust migration induced by solar wind, local magnetic fields, either inducing migration, migration of dust that contains nanometer-sized iron particles, or even protecting that dust from solar wind-driven migration at all. They've also considered interference between solar wind and local magnetic fields that generates local electrical fields that can levitate the dust, and topographic highs and lows where the dust becomes trapped and protected in the lows. The problem with the last one is that the association of the lighter colored dust with the topographic lows is only statistical. In other words, mostly it occurs in the low spots, but not always. Not very convincing. So in 2024, lunar scientists concluded in a paper that it's likely that all of the above may contribute to the formation of the bright dust swirls. They just don't know yet how, which is fair enough. One more, there we go. So I wish the Artemis program well. I just wish it wasn't sucking all of the air out of the room and distracting science journalism from what else is happening in lunar science. Many individual scientists and small teams are doing good science on the moon, and some are still wrestling with questions first raised up to half a century ago. More power to them. As always, thanks for listening.
Very good. I'm using my prerogative here to actually ask the first question. Do I understand correctly that these types of evidence that you've been going through tonight demonstrate that not only is the moon made of cheese, but it's a blue vein?
Well, it's actually a wet cheese with a blue
there it
vein.
is.
And it's wetter than you think.
Okay.
And this may have consequences for your digestion.
Yeah, I'm thinking more of Wallace and Gromit, but do we have any other questions online, Chris? Nothing online? Anyone in the audience got a question for Simon?
Other
Okay.
than on the topic of cheese.
Okay, thank you.
My pleasure.
Where's the clicker? What have you done with it? Good. All right, Gordon. You're all hooked up?
Almost. Alrighty. All right, so I'm here to talk just a little bit about the RASC Ottawa's Discord server. It's a free service on the internet available to all members. And all you need to do to access it is basically get an account. And so I'm going to show you a little bit about what's on the server. And then I'm going to, if we have time, I'm going to try to show you how you sign up for an account. So what we're looking at here is the Discord server. Now, okay. So it looks overwhelming, and it can be a little overwhelming. But basically, on the very left here, you can ignore that because Discord is it's a whole network of all different servers for all different topics that you could possibly think of. I have subscribed to a few, many of them actually space related, and some of them aren't. Our server has a number of channels here, and the channels are grouped into general headings like general, some more about the related sort of RASC Ottawa operations. We've got channels about telescopes and equipment. We've got very active observing channels. We've got channel here for astrophotography. And if we just poke into one of these, we'll see that people are posting images that they've taken. They're talking about it. You'll see a lot of names that you recognize. Richard posted something a couple of weeks ago that he took, I think in August. And so you can participate in any of these channels by simply at the bottom, you can just, I'm going to go to the general channel because I will clean it up later. But you can basically post a message. I can see Oscar is there, so I can say, hi, Oscar. And that will have made Oscar's phone make a noise, his iPad make a noise, his computer at home make a noise, and he's probably going to go and respond to everything. You don't have to put a name there, but if you do, that will tag the person that you've mentioned, and they'll get an alert depending on how they have their alerts set up. Everybody gets a little icon. The person who posts message, it's their name there. You can control the name that you want to show when you set up your account or even afterwards. On this server, we ask people to use your real name or some abbreviated version of your real name. But there are people who they use a handle. On a lot of servers on the internet, I use the handle Keeper of Maps. It comes from geocaching, and it's what I'm known by in a lot of places. There are some special channels we have. I'm not going to click, I can click on it, but I'm not going to do anything, and I've got my sound muted. But we have voice channels in here as well. And so if you go to one of these voice channels, you can actually talk to other people in that voice channel. And I'm going to disconnect from the voice channel because that would just cause chaos. But the way I did that was down at the bottom. When I connected, it said, it's trying to connect. I don't know that it'll actually let me to connect from here. But if there are people who are having a discussion, they're trying to coordinate maybe an imaging run or something else, they can look in these channels and you'll see them. They've got a little speaker symbol like that. And we can create these, the mods of the Discord can create these channels, like special voice channels as required. We can create new channels and to support the conversations. And so one thing is, I did mention mods. There are a subset of users from the chapter, or from the center rather, who have more than average privileges. So, and this is not personal, Oscar or Dave, but we can just go, well, you know what, Dave, that message wasn't good. And we can report it. If we see it's an abusive message, there's more that we can do. We can report it if there's a safety issue. We can take actions against the users. We can kick the user or ban the user from the chat and from the server. And so Dave's message, no offense, Dave, no longer exists, and it will have disappeared everywhere. So the way that you get a Discord account is you can go to discord.app. It will tend to redirect it to a longer one, which is discord.com/login. And on that screen, you can register. And this is where you need to provide an email account. And I created an email account for this. And we're just going to do this. And we're going to let it use a strong password. Use strong passwords. Turn on your two-factor authentication and other ways to protect your accounts, because otherwise there are unscrupulous people out there. You need to be more than a certain age to use Discord. I don't remember exactly what the age is. And it didn't like my password. What doesn't it like? Use only numbers, letters, underscores, or period. Oh, there we go. It didn't like that, like my password. And so what this is going to do, yeah, that's not my real name or my real birth date. It will ask me to the hell? Click on the entity that can be seen in the sample image. Well, they're all freaking panda bears. This is, oh, you gotta be kidding me. Okay, when I set up my account, Okay, so of course it is. Womp womp. Alrighty, well, that's fun. But so if you do have a Discord account, you can log in through the web interface, and there's a couple of ways to do that, but I will use mine, and I will go to there. And I believe when you're a new account, you land on the rules channel. I don't recall if we have to agree to something. It's been a long time, and I was one of the people who helped set this up, so I don't have to go through this. But basically, read the rules. The rules are very simple, and it really boils down to be nice, don't be antisocial, use your real name, please, and exercise some discretion in the language that you use, or people will come along and clean up your content. As Mick said, too long, don't read, or didn't read, keep it relevant, keep it polite. So you can access this through a web browser interface, and the web browser interface is pretty good. But I was talking to Chris earlier, and he said, I have a Discord account, and it sends me a notification when somebody mentions me, but I can never find it. And I said to him, are you using the browser or are you using the app? And so the other way of accessing Discord is going to be through the Discord app, which you can get through, you can get it through the Discord website. If I can make this little bar go away. There's a bar you can't see. It was the one that was plaguing Cassandra. And if you go to discord.app and you're not logged in, because I'm logged in, so it's going to do that. So I will log out so that you can see it. It should, maybe it's just on the main website. Sorry. You can download, and actually you'll notice it will figure out what type of computer do you have. I have a Mac. You can download the app. It's very easy to install, whether it's Mac or Windows. You log in, and you will end up with an app that looks like this, which is pretty much exactly like you would see in the web app. But you will also get nice notifications from Windows or from Mac. You also have apps for your phone, which makes it very easy to keep yourself connected, and you can control the notifications you get. Some servers are very chatty, and so you might want to say, well, you know, notification settings, I only want to hear when there are mentions. So when someone mentions me, or there are certain special roles that can be mentioned where it will mention larger groups of people. Or you can say, I don't want to hear anything, or I want to get everything. And if you have this turned on, mobile push notifications, it'll pop up on your phone and keep you amused for hours and drain your battery. No, it's actually not that bad for the battery. Whether you're working on your phone, on your computer, through the browser, through the app, you can do it all simultaneously. You can change conversation, you can change from phone to browser to whatever in the middle of a conversation. No one will really notice. You can access the voice channels, and the voice channels actually do support video, so you can stream, you can share your screen into the channel and show people. And it's largely, it's what you want to make out of it. The only other thing I will mention is on the left here are the people who are, or sorry, the right here are the people who are online. And you can see some people have different colors. The colors do relate to their roles on the server. And you can see all the people who are offline, but that means they've joined the server. There's lots of them. I'm going to go here and for Oscar, I can actually send Oscar a direct message and it'll go right to his phone. And it'll open up in another part, it'll open up conversations that you have with various people. You can see that I was talking with Andrea. This is a person down in the Toronto Center. A lot of these people are people I know through a citizen science community. I can add Oscar as a friend. I can report him as a spammer. I won't do that to Oscar. I could block him, he could block me. And you can find out, well, we have one thing in common. And we can find out somewhere, if I click somewhere, I can find out what it is. So to get on the server, it is an invitation type server. If you look in Astronauts, there's a link. The links have a relatively, to join, the links have a relatively short lifespan. But if you email any of the, if you email the executive, president or whoever, or you email Andrea, she can send you an up-to-date link if the link has expired. Are we doing, I think that's about right, because I gathered there's lots of observations. So that's Discord in like 10 minutes. I'm happy to answer questions now or later. And if you have problems, you can reach out.
Any questions? Apparently it worked.
Excellent. You're very welcome.
Okay, thanks, Bill. Alrighty, so here's the order of battle for the presentations. Again, please move it along. As you can see, this is one of the longest lists we've had all year, other than Eclipse Day. So, Bob, if you want to lead off. That too, please. And clickers.
Big one, right? Yeah. This is one of the prettiest, geez, clusters that I've seen in a long time. Now I've imaged this before, but it's very convenient in the sky right now. Okay. This is the Bubble Nebula, and it's found in a big cloud of hydrogen gas, and right in the middle of it, there's a very bright star, and the shock wave of that star is emitting stuff out of the star has formed this bubble in the middle of it, and the radiation from the star has lit up the nebula, so it stands out. The bad thing about it is I don't think you can see it. It's red. We don't see red very well with a naked eye. This is a very bright cluster of stars again. Visible easily with a small telescope and very easy. The brightest star in this cluster is the brightest star that is in the sky. And I don't mean the brightest to us. I mean absolute brightness. It's the brightest star in the sky. If our sun was there instead of that bright star, it would be magnitude 17, which basically means we wouldn't be able to see it. And it has other names too. It's sometimes called the owl cluster. And if you look closely, you can almost see the owl. My favorite, though, is the ET cluster. Anyway, very interesting. I want to say binocular, but maybe on the edge of small telescope for sure. This is the prettiest thing in the sky for astrophotographers. And the red is a emission nebula, and the blue is a reflection nebula. So the light is being reflected off of it. In the emission, the red emission nebula, it's being lit up by the stars. And this is the Crab Nebula. I've imaged this lots of times before. It was back in the 1000, it was seen by Chinese astronomers, and they recorded it, and so we know what then it was seen later on in the 1700s, and it ended up as Messier's #1 thing in his star catalog. And his star catalog was things that look like comets but aren't. So don't record them as comets. And the Crescent Nebula, again, very pretty object. By the way, I should, how do I go back? Which one is it? Oh, the small one on the left, right?
Left.
Yeah, right up there. Sure. Okay. Yes. Yeah, the Crab Nebula. I wanted to say one other thing about the Crab Nebula. I've imaged this thing lots of times before, but in September, the seeing was really steady. And I've not seen this much detail in it before. And this is the Crescent Nebula. Again, hydrogen alpha shows up the red. Thank you very much. I think that's the last, eh? Yeah. Okay.
Okay, here we go. So, and where is my? Okay, the green. Okay. I often revisit the Lagoon Nebula during the summertime, and I took this image in August. It was taken by the Malincam Skyraider camera using an IDEAS NBX filter. It's approximately 15 minutes of exposure time. So this is a huge H2 region in the constellation Sagittarius. And the hydrogen emission is caused by a nearby massive star called Herschel 36. The Lagoon Nebula spans 110 light years, and the nebula also contains several Bach globules, which are dark collapsing clouds in the process of forming new stars. And you might be able to see a couple of them, little Bach globules. So that is the Lagoon Nebula. Now we're going to move on to the Wizard Nebula. Wizard Nebula, also known as NGC 7380, is an emission nebula in the constellation Cepheus. And this nebula surrounds an open star cluster and is situated approximately 7,200 light years from Earth. This is another active site of star formation where many young stars are emerging from the surrounding gas and dust. For this image, I used a 6-inch Smith-Cassegrain Celestron telescope with a Malincam Skyraider camera and the MBX filter for approximately 15 minutes of exposure time. We have 2 more to go. And this is Sharpless 2-103, the Cygnus Loop, which was taken with a 61 millimeter William Optics refractor, a focal reducer, and a field flattener
yielding an F ratio of 4.7. I use the Malincam Sky Radar camera and the NBX filter. And this is a large supernova remnant in the constellation Cygnus, approximately 1,500 light years from Earth. And as you can see, I just had enough field of view in the frame to capture this huge emission nebula, which spans 120 light years in diameter. And the last image I'm going to be showing you is an inverted image of the sun using the program IMPPG, highlighting the surface and prominence detail with some filaments showing up rather nicely. Here I was using the Lunt 60 millimeter H alpha scope with the ZWO ASI 174 monochrome camera. And this image represents the best 10% of 2,000 frames processed in auto-stackered, IMPPG, and Affinity Photo 2. Thank you.
Who remembers who's up next? Hello.
Need to change spectacles here. Well, good evening, everyone. We had a lovely month. I hope everybody was able to get out in September to see the nice clear skies we had. I'm going to give you a rundown of what I was up to. I'm sure you're all missing the sound of my voice being away all summer. So the month started out for me at a video star party hosted on the 5th. It was hosted by a friend of mine, Waldo Krolak, at his cottage on Calabogie Lake. This is a picture of the group of us set up on the shore of the lake. Starting on the leftmost side of the image, that's Jim Sophia's setup, and then I'm next to him, and then Simon, and then Lance McIntosh on the far right there, being lit up like the sun by his monitors. There's a 5th person, Waldo. His setup was in the foreground, but he's facing away from the camera, so you can't see him. So it was a fabulous weekend ahead of a pile of rain. I think it was actually one of those weekends where we had the rainfall warnings, but the Thursday night was awesome, and the skies were very dark at that location. It was so great that I was able to observe constellations and objects from 3 seasons in one night, summer, fall, and winter. I ended up going to bed about 5:45 in the morning. So I've just put 2 samples from that evening. I had lots of captures that night, but my 2 favorite ones I'm showing. The first one is from of the North American Nebula in Cygnus. And I've put 2 images side by side. I had 2 cameras on 2 scopes on the same mount, that cute little Sky Hunter mount that I told you about a few months ago. The image on the right is Malincam DS432 monochrome camera with a hydrogen alpha filter on ASCAR 180 refractor. That's a 40 millimeter diameter refractor. And the H alpha filter really pulled out the detail I found in the nebulosity, kind of giving it a lacy texture. The image on the half on the left is my continuing effort to further expand my field of view. 40 millimeters was not enough. I had to go even wider. So this was ASI 533 camera on a 50 millimeter TV camera lens, an f1.4 lens that I had set down to f4, and it had a dual 3 nanometer ultimate filter on it. So the field of view there, I'm not sure, it's big, and I like it because Look at all the glorious stuff going on around the perimeter of the North American Nebula that you wouldn't even know was there. It is, yes. So Canon, I guess, back in the 60s and 70s, made lenses for many applications, and one was for TV cameras. Yeah. It's amazing what you find on eBay. This is the second shot, second favorite shot from the night. It is of IC 1396. Some call the Northern Rosette. Some people just call it according to its main feature, which is the elephant's trunk. Just feature right here. I guess some people think it looks like an elephant's trunk. So it's a big star forming region in Cepheus. It's nicely placed in the sky right now if you want to take a look at it. You'll need to be at a dark site though. I really love the extent of the dark nebulosity, especially around the lower portion of the image. I thought that was really, really neat. And then when you look at the extra wide field, you can see how all of that dark nebulosity is actually interwoven and connects through a vast region in that part of the sky. A couple other objects that are visible in that big field of view is Sharpless 2129, the flying bat, which is that sort of C shape up and to the right. And then Sharpless 2132, right at the edge on the left side, called the lion. So yes, that's two of my favorites from that night. So moving on, my next observation of the month was of the partial lunar eclipse on the 18th. Do I press again to start the play? Oh, somebody's moving the mouse. There we go. So this is a time lapse over about 90 minutes. I caught it after it already started. Was able to catch it, the Earth's shadow moving off the moon. This is the first lunar eclipse that I've been able to see the whole thing without it being clouded over. So I was quite happy about that, even though it was only a partial. Sticking with the moon theme. Go right back. There we go. I was able to get 3 consecutive nights of lunar imaging in this month, the evening of the 19th, 20th, and 21st. This particular image I call the crater conga line, starting in the upper left. Up here, that's Langrenus. My Latin pronunciation is probably terrible. And then Vendelinus, Batavius, and then down here in the bottom is Furnurius. Yes, oh yes, I wrote it down so I'd remember. These craters are all similar in size, between 130 and 180 kilometers across. Batavius is particularly interesting because it has lots of rifts in the floor, kind of radiating out from the central peak. And I was very happy to capture these craters at this time of the lunar cycle because it's way over on the right limb. So you have to catch it just a couple of days after the full moon, which means you have to wait until, 1 o'clock in the morning for it to be high in the sky. So it's not really super convenient to see this phase, but it's totally worth it if you make an effort. In that same 3-day period, I did get some solar imaging in. This was from the 20th and is just the southern hemisphere of the sun. You can see there's lots of filament action and lots of sunspots spewing out X-ray flares at a furious pace. This particular image was captured with a new procured addition to my solar observing kit, a double stack to go on my hydrogen alpha scope, and I will, if you ask nicely, tell you more about that at a later date. Getting back to the moon theme, this is a image taken of one of my favorite craters, Posidonius, on the 3 consecutive nights, showing how the shadows change over the course of those 3 days. It's a 95-kilometer diameter crater, and it has a very unusual floor in that it, instead of a central peak, has sort of a heaved up, kind of almost a spiral shape. And it's believed that that upheaval was due to the movement of lava under the crater's surface well after the crater's formation, related to the lava that you see, the dark areas around. So an interesting crater to observe for sure, if given an opportunity. Now, I purposely put these 3 images as well aligned as I could, side by side, because if you now cross your eyes just the right way, you can combine the images and create a stereo vision image of the crater. You can see it. In fact, if you cross your eyes far enough, you'll see the 3 images change into 4, and the 2 images in the middle will be in 3D. And once your eyes kind of lock in, you can kind of peer around and look at the details in 3D. It's kind of cool. So fun stuff. Another interesting observation from this particular combination of images is if you look carefully, you see this little crater here, and this crater, these craters here, they're all about in the same position. But now look up down. You can actually see progressively more in the vertical direction. Like, see this crater here? It's almost off the frame, and here you can't see it. So somehow the moon is being stretched. But in fact, what's happening is we're seeing evidence of libration, which is, from our vantage point on the Earth, it looks like the moon is doing a wobbling, because it's in an elliptical orbit. Sometimes we're below its orbital plane, sometimes we're above. And because it's an elliptical orbit, sometimes its rotation is ahead of its position in its orbit, sometimes it's behind. So through the month, it does this wobbling. And even over the course of 3 nights, I was surprised how much different the moon's surface looks because of libration, just in that short period of time. So anyway, that was an interesting, unexpected observation. I forgot to mention this, all the lunar images were captured with my 10-inch Ritchie Chrétien, and they're the best 200 frames out of 4,000. I usually have to go a lot of frames because the seeing in the city is terrible. And next and last is my my picture of comet C2023A3. I'm very proud of this picture. As you can clearly see, the comet was there. It was so we took a chance, my Astro buddies and I, Simon, Jim Sophia, and newcomer Francisco, to get up early before the sun came up. We found a dark spot off of Innes Road near Blair in a farmer's field to try to see this comet in the morning sky. We might have better luck now later in October when it's in the nighttime sky, but we figured we'd give it a go. And perfect conditions, beautiful sight, and no comet. And after the fact, I checked all of the charts, and it was indeed in the sky at the time I took this photo, but it was just too close to the sun for it to be seen above the sun's glow by the time it was above the horizon. The further south you were, the easier it was to see, apparently. I even tried zooming in and stretching the heck out of the image. There is a streak there. It's in the right spot, and it's the right orientation and size, but yeah, that could be a cloud or noise or who knows? So, yeah, exactly. So I'm not gonna say that that's the comet, but we'll try again. We'll try again this month. That's it for me. Thank you.
All right. Good evening. There we go. All right, so my first image here is of the Cygnus Wall. Cygnus Wall is part of the North American Nebula, which Jim showed a beautiful image of earlier. So it's a dense portion of the larger nebular complex there, and it exhibits more concentrated star formation when you get all of that hydrogen gas kind of all piled together. So what it forms, it's like the Mexico. Oh, where's the pointer? Is it this one? So it's kind of like the Mexico or Central America portion of the North American Nebula is what the Cygnus Wall ends up forming. Yeah, so this image was taken this past July, the 20th and 31st. My 11-inch Schmidt-Cassegrain with the ASI 2400 MC Pro. It's a total of 10 hours exposure. So something I've been playing around with in software is you can use AI tricks to get rid of stars, which I find is an interesting way to look at images like this, because it really brings out I guess it kind of takes away some of the distraction that I think stars produce in these images, and you can kind of look at more of the structure of the nebula. So it's kind of a fun trick that I've been playing with. And then you can bring the stars right back. All right, my next image here is the Cat's Eye Nebula. It's also known as NGC 6543. It's a planetary nebula in Draco, about 3,300 light years away. Discovered by William Herschel in 1786, just yesterday. It's a bit of a challenging object in that you have a really dim halo. So my goodness, this too remote thing. You have a really dim halo that is kind of around the planetary nebula, and then right in the middle you've got a really bright core, which is kind of cool. But you can get a lot of detail in both objects. So I took this image actually last year, June 19th and 21st, 2023. Same setup as the previous image, the 11-inch with the 2400 MC Pro, and this is 8 hours and 21 minutes of exposure. So there we go. This next image here is the Wolf's Cave, which is a long, this long nebula there. It's both a dark nebula and a reflection nebula in Cepheus, 1,300 light years away from Earth. I took this image about a year ago now, the 19th to the 22nd of September 2023, using a Skywatcher Equinox 80 ED, so a small 80mm refractor with the ASI 2600 mm, so it's a mono camera. 11 hours of luminance data, 4 hours of red, 5 hours of blue, 3.5 hours of green. So it's again, I'll hide the stars, and you can kind of see a lot of interesting kind of details that are revealed once you hide the stars. Something that I think I'm going to come back in image and maybe show next year if I get more imaging time on this is there's this really kind of cool red streaking that's here and here. So I'm going to go back and image that with a hydrogen alpha filter and see what I can bring out and add to this data set. So maybe keep your eyes peeled next year for another showing of this image with some hydrogen alpha data. This next image here is the Cave Nebula, or SH2-155. It's an emission, reflection, and dark nebula all in one. It's in the constellation Cepheus, so it has H2 regions with ongoing star forming activity about 2,400 light years away. So this image was taken again last year, September 21st to 22nd, 8-inch Schmidt-Cassegrain, It was actually the last image I took with a camera I sold that I quite liked. It was the ASI 533 MC Pro, and it's 12 hours worth of exposure. That's it. That's it for me. Thank you.
Good evening, everyone. And for me, today's presentation is about the comets. Let's see if I can handle the remote. So this one called 12P Pons Brooks was conclusively discovered at Marseille Observatory in July 1812 by Jean-Louis Pons. And its next appearance in 1883 by William Robert Brooks. That's why it has two names, Pons Brooks. The time between these discoveries is 71 years, and it is the orbital period of this comet. This picture was taken March 8 this year, around 10 p.m., when the comet was of magnitude 5.5, and it was located about 10 degrees far from Andromeda Galaxy. So following days, the comet was reported to be visible by naked eye and featured a tail about 5 degrees long. This picture with part of Andromeda Galaxy in it, like previous as well, was taken with 135mm telelens from Norway Bay location on Quebec side, just above Ottawa River. I could see the core with the naked eye, barely, but the tail would only show up in the pictures. My telelens was too narrow field of view, and I was unable to fit it nicely with Andromeda in the same frame. So a few days later, on March 12th, I obtained a 35mm f1.4 lens, which is stopped down to 2.2 f2.2 in this picture. And I went for comet hunt again, this time with Andrew Brown, to the place that we found on Google Maps, which happened to be near a dam of Carillon generation station near Hawkesbury. You can see the town itself in this picture, those lights on the river, and I was happy to find out that the comet, Andromeda Galaxy, and even M33 Galaxy fit nicely into this frame, and M33 can be seen as a faint smudge in upper left corner. The scenery was beautiful. As few more days passed, the comet was brightening up, and I wanted to get more details in its tail. So my next trip was to Norway Bay again on March 31st. This time I imaged the comet with my 380mm refractor, and this picture showed some details in its tail, like spike-like ejections that faint with the distance. This comet was known to have a couple of outbursts. One of them occurred on April 3rd, and as the result of that, the comet has brightened to magnitude of about 3.8. But I could not see it from Ottawa that day because of the weather conditions. However, the same night on March 12th, after replacing my refractor with more powerful in terms of magnification Schmidt-Cass and attaching my monochrome planetary camera to it, I was able to image the core of the comet, which looked like a rotating blob ejecting some comet matter into space that gradually darkened as it dissipated. This picture is fake color. It was created from a monochrome image. I chose the palette that match those colors seen in a wider field of view pictures, roughly. So the streaks are just the star trails, not that pleasant looking, and it's quite noisy, but you can see a little bit of details, especially how the gases kind of spin around the core. The comet season wasn't over, and as the matter is not over yet. Astronomers have been expecting another much more brighter and more beautiful comet to show up this fall. See 2023 E Tsuchinshan Atlas. This is the one which Jim just mentioned that they tried to observe the same day as me, as the matter of fact. There were already many wonderful pictures of this comet published on the internet in the second half of September. And the planetarium software, as you see, promised views like this for our latitude, with quite bright core of magnitude 1 and the long tail spreading far into skies, dozens of degrees in length. The only problem, it could have been observed only 1 or 2 degrees above the horizon in early morning hours of September 27, 29th. So on September 27, I went to Westmeath Lookout with Konstantin Popov, whom I promised a good view of the comet with a great material for time lapses, if only we wait there long enough to see the rise. We started taking pictures way before the expected comet's rise, which would be around 5:50 p.m., hoping to see that bright tail first. Nothing. Waited a few bit more, still nothing. Already past 6 o'clock. And the skies are getting quite bright now in the morning dawn. Analyzing the pictures later, I saw a faint smudge in them, in the place where the comet was expected. This image is composed of about 40 such frames stacked. Nice scenery though, and the view from that lookout was magnificent. We saw the fog rolling in the sunshine through the fog, and the sun throwing its shine through the fog on our way back. So this is a cropped part of the image that I processed more aggressively to reveal a bit more of the comet's tail. So what went wrong? Location matters apparently. Not all of what looks like from the southern hemisphere, where all those beautiful pictures were taken, would be the same in our northern hemisphere. And it's not a surprise. In our latitude, the comet would be observed under roughly 30 degrees angle with relation to the sun, which means that the background sky was already quite lit by the sunlight at that time. So chance for success were quite low to start with. But there is good news. So when the comet continues, you can see the comet at the bottom and Earth on the right as a blue dot. So we are here about now, and in a few days on the 11th, we'll see the comet passing the line between Earth and Sun, and then going on the other side, which means that we'll be able to see the comet rising, or rather setting to close after the sunset. And with the span of days, it's going to be later and later, which would make the comet more observable, but it will be also be getting dimmer and dimmer as it advances away from the sun. Thank you.
Well, good evening, everyone. I've got a couple of things to show you. First of all, auroras. We are in the midst of a wonderful aurora season, supplemented by the active portion of the solar cycle that the sun is in now, plus the fact that auroras tend to be a lot more common around the time of the equinoxes. So which we are just past. So we saw this beautiful display in May. I'm still processing images from that. This particular one was shot, this was back in June, actually. This is the August one. This was a shot after returning from Starfest. It was the night after a bunch of us were down at Starfest there, and I returned on the 12th there, and there it was, just as I was getting home there. So didn't have enough photography at Starfest, so we managed to grab some auroral images.
beautiful stuff there. And I think there's more to come. I actually just heard that NASA's Solar Dynamics Observatory yesterday photographed the strongest solar flare that's been emitted or observed in the last 7 years. So potential for some action in the next couple of days. We'll see. This is another one from the same night. This is right after the Starfest that ended down at Mount Forest, and with a wide-angle lens, 8mm lens there. It was quite an interesting aurora because it really it changed color and the dynamics of it, the structure of it varied quite a bit over a span of just about an hour and a half. So nice occurrence there. All right, comet. Yes, I empathize with Taras and Jim for their efforts on trying to image this thing. I also was out on the 27th, 28th, and 29th, which is last weekend. I was stationed down in a place near Richmond where we had some very nice clear skies, but it was foggy most of the days, most of those mornings there, that morning haze, and above was crystal clear. But as Taras mentioned, this is where the comet was. It was just at rising as the light of the morning sky started to improve, or it started to increase rather. So it was really tricky. You're looking through a lot of atmosphere. This shot was taken with the comet just about, not quite 2 degrees above the true horizon. So I had to find a place that was very flat, give me a view above the tree line there. And I was dogged by clouds. We had that massive system to our south last weekend that our high pressure system kept at bay, but going further south, you neared the edge of that. And so I actually photographed this through some clouds. I thought I was going to be wiped out on that day because they were just at the boundary where I knew that the comet would be. I was there for about an hour trying to set things up and photograph it. I got a pile of images, but actually only about 2 or 3 images where the cloud didn't interfere. But fortunately, the universe smiled on me, and I just got that last little break before it got way too light to observe it. So this was taken with actually just with a 200mm lens and an ASI 294 MC Pro. So the coming week, if you're into comets, you want to try to pick out this thing towards the end of the week, this is going to be their sweet spot for us. And by all accounts, it's healthy, and I've even heard some estimates saying that it could rival some of the brighter comets that we've had in the last few years, including NEO-wise. Find that a little hard to believe, but we'll see. Comets can be notoriously unpredictable. So cross our fingers there, and we'll see. Okay, last one, another aurora shot, but that's not really why I'm showing it. I just thought it was pretty. This is our site at FLO, showing the 2 domes that we have up there. The reason I want to show this was it was also an auroral display, and this was just taken a couple of weeks ago because I've been doing the work on this. And I apologize for anybody that's in the audience that's been hankering to get their fingers on the 14-inch scope. I apologize for the numerous delays we've had. We've worked through technical glitches, mouse nests, a number of different things. But I'm happy to report that I think I've pushed this thing as far as I can take it, and it is ready for people to get some training on it if you're interested in this scope. I will be issuing an email on the FLO site within the coming week. That will also contain my preliminary version of the user manual. The scope is not easy to use. It's a 14-inch Schmidt Cassegrain, and this was donated by Paul Commission to the club. And it's a beautiful scope to image with, maybe not so much to work with. It's a finicky beast, but you can make it do its thing and get some interesting results. So what I'm going to try to do here is get the notice out, get the manual out in the coming week, and then we'll set up some training sessions. What I'd like to do is, for anybody that's interested, we'll go through things during a daytime session because it's a very crowded environment in that small dome for a scope that size. And so there's a lot of precautions and gotchas that can get you while you're working with that instrument. And it's a lot easier to see some things that I need to indicate to you while we've got some light to work with. So that'll be a sort of the preliminary step in the session, is to just get familiar with it and see the things I talk about in the manual. And then we'll do a night session where you can have at it and give it a try. So fingers crossed that she holds together. I think it'll do the job, and I'm looking forward to seeing it. We've got a few folks that have been trained on it that have helped me out actually with debugging it and getting used to how to use this thing. So I appreciate that, and hopefully we'll be able to open that enjoyment to other folks. So stay tuned. Thank you. Have a nice weekend.
Thank you, Paul. Who's up next? Oops.
Okay. Hi, everyone. Okay, it's getting a little bit late, so I'll try and make this quick. This is the OWL cluster again, NGC 457. Discovered by William Herschel in 1780, I think. It's brighter than a lot of the Messier objects, and it was discovered in time, but it didn't make the list. Sorry, Herschel. I like the ET description that we saw earlier, two sort of googly eyes and a couple of arms there. Also look at the little cluster down below. That was another one of Herschel's discoveries. Second, not very far away from that cluster is the Pac-Man Nebula. This was a narrowband image. I put quite a lot of time into this. We had so many good nights that I figured I would just spend a bit of time. So the blue shows up the oxygen, and the red some of the hydrogen and sulfur. Look at the dark lanes and some nice star formation, I think, right in the center there. And finally, I went towards Cygnus. This is right in the middle of the summer triangle. Cygnus is the bright star you can see in the center, and the big dark patch above it kind of describes the Butterfly Nebula. You can see the two wings to either side, and this again is in narrowband with some nice blue oxygen on the left, and I think sulfur showing up in the red highlights. And this was, the details are there, imaged this past month. Yeah, that's it. Thanks very much.
Okay, this is something's a little, I thought it was, okay, I've got the order different. The one at the top again is the Bubble Nebula, the one that Bob Olson was talking about. This is in constellation of Cassiopeia in the Milky Way, and it's one of the few gaseous nebulae in Cassiopeia, because most of them are open clusters. The one at the bottom is Messier 52, the one discovered by Charles Messier. And a close-up of the Bubble Nebula. This was only, I think, 10-minute exposure. It's I stretched it so it's a bit grainy. It probably could have used probably 30 minutes or more. And by the way, all of these pictures are taken with this automated telescope, the C-Star that I demonstrated and showed 2 months ago, 2 meetings ago. This is another open cluster in Cassiopeia, Messier 103. I believe those two, M103 and M52, are the only two Messier clusters, although there are a number of other ones in there that one of my favorites is NGC 7789, which is off one of the easternmost stars of Cassiopeia. Now this last one, it's a little different. When Dave was going down the list of all the planets, he only went as far as Neptune. and he forgot about Pluto, although I guess Pluto's technically not a planet anymore. I can't remember what it's classified as. A dwarf planet, okay. But a week ago, I saw somebody that I know was down at the Okie-Tex Star Party, and he showed 2 pictures of Pluto. So I looked it up, and it's from about 8:30 till 10 p.m. It's right on the meridian, right due south in Capricorn, just north of, to the bottom of Capricorn, just above Sagittarius. So I got pictures on the 28th and the 29th, that's Friday and Saturday of a week ago. Now I had to blow this up quite a bit, but do you see the object that's moving? That's 2 images blinking. Yeah, there they are. Now, now that's 24 hours of motion. Yeah, that's an 11. I wish I'd looped it, but anyway, it's not about 10 seconds. That's 15th magnitude. And these were, one was 20 and one was 25-minute exposures. You can see they're a little bit different. Oop. Oh.
Can you go back to Pluto again, Chris?
Now, the thing is, though, most Pluto is actually in retrograde motion right now. Its normal orbital motion is west to east, but we're seeing it move east to west here, and that's because Earth is overtaking it and making it look going backwards. So almost all of that motion is actually parallax due to the Earth's orbit. Like if you can imagine, if you open and close your like right eye, left eye, right eye, you'll see things sort of shift back and forth. That's exactly what we're seeing here because of the Earth's motion, except it's not back and forth. It's just 2 days, and the blinking program is making it alternate. So that interval in 24 hours is about 0.7 or 0.8 arc minute, whereas the actual orbital motion of Pluto is about a quarter of an arc second. So that's a factor about 200. The parallactic motion is about 200 times greater than the actual orbital motion of Pluto. But what's amazing though, I mean, this is a device with a 50mm lens on it, and we're getting close to 17th magnitude. And it's not even a really great skies. I think a Bortle 5 or so, because there was a bit of haze and moisture in the air those nights. Yeah, 2 nights there. Oh, and by the way, I also tried on the 27th and 28th to see the comet and didn't see anything. Although I did get a picture of it back, I think it was in May or June. It was around 6th or 7th magnitude then, and had a nice half a degree tail on it. But I'm not sure if I showed that picture. But anyways, that's it. And we'll, I think there's one more person.
Okay, so I've got pictures of the monthly challenge objects for this last month. This is actually taken a little bit before. I was out at North Frontenac with some very, very dark skies, so I took the opportunity to get some lovely pictures of Cassiopeia. But this is just with a very simple lens. It's a 45mm kit lens that came with my Canon camera. I did have it on a star tracker, but the dark skies really helped in getting a lot of terrific Milky Way shots. So you can see on this picture a lot of the clusters that we've seen close-ups of already. Yeah. So down here is that owl cluster, and because it's, even the shape of it is just visible on this picture, it's obviously going to be quite easy to find in binoculars. And then there's a whole bunch of other little clusters in this neighborhood as well. M103, I think we saw earlier, was there. I'm going to show you this one here. NGC 654, the fuzzy butterfly. And there's one over at the other end here, which I'd forgotten about earlier, but Caroline's Rose, NGC 7789. That's a lovely cluster as well. And all of these you can spot in binoculars. And then the Pac-Man Nebula, we've already seen a couple of pictures of that. That's right down here. And on the original picture, I can actually see a little bit of pinkish glow in my photograph drive from this one. So lots of interesting stuff happening in Cassiopeia. So here's my version of the owl cluster. For this one, I put my little crosshairs on the front of the telescope to give a nice sparkle to the eye. And Pac-Man. I really like the way we can, the eye of Pac-Man and the mouth there. All depends on which way up you turn your camera. Now, another one that was not visible on my picture of the entire constellation, I really had to take a long exposure on this one, but there's actually another galaxy in our local cluster, and it's not easy to see and not easy to photograph because we're looking through the actual dense part of our own galaxy. So that's one of the reasons why this looks a kind of, whoops, sorry, wrong one. Can I go back? It looks kind of an orangey color here because we're looking through the dust in our own Milky Way to see this galaxy. It's a fairly small one, somewhat around the scale of the Magellanic Clouds, but they call it a starburst galaxy because it has an unusually high number of Wolf-Rayet stars that are literally bursting apart. So it's an interesting one to keep an eye on. Perhaps some more supernovas will happen in this area sometime in the future. Here's one that wasn't a challenge object that maybe should have been, Caroline's Rose. Just a lovely dense portion of the Milky Way. And that other little cluster, the fuzzy butterfly. Now, I took this from my own backyard in Ottawa here, so it didn't show the interesting feature that I was hoping to catch, but you can just kind of barely make out that down here, there seems to be a lack of stars. And that's it's a dark nebula in this region. So from a darker location with a long exposure, you could probably see some interesting dark nebulas in that area. And then the solar system challenge was Neptune, not Pluto. But Neptune is also quite nicely placed. It was at opposition this last month, so very nicely placed high in the sky near the meridian. And I took it on 2 different days in September. And if you look very, very closely, you can see a little tiny dot beside Neptune. And that's Triton, its biggest moon. And I thought it was kind of interesting to see that it looked like it had moved a bit between the 10th and the 15th. But then when I looked in Stellarium to see what the orbit was, it had actually gone 3/4 of the way around its orbit between those 2 days. So yes, you can see Neptune, and yes, you can see the moons of Neptune. Okay, so that was the challenge objects for this last month. And gold stars for Tony Jarrett and Taras, and for the other people who showed their images tonight as well. So I'll have to add a few more into my list on that. For this next month, another constellation in the northeast right now. This is Perseus. And the particular objects in Perseus, again, it's close to the band of the Milky Way. So one of the interesting things you can see with binoculars is the double cluster up here. Not a Messier object for some reason. It was certainly bright enough and easy to find, but it never got into Messier's list. So it's in the Caldwell catalog now. The next object is one that is going to be a challenge for me. I have been doing astronomy for something like 60 years, and I've heard about this object many, many, many times, and I have never actually observed it. And that is Algol, a fairly bright star, but the unusual thing about Algol is that it's a binary star and it eclipses itself. One of the two stars passes directly in front of the other one, and it's dimmer, and so the star looks dimmer for just a few hours every couple of days. And this has been known for a very long time. In fact, it was known as the Gorgon's Eye. It's the head of Medusa, and it's still blinking. So it's been known from prehistory. And it's kind of an interesting thing because this is exactly the same kind of thing as we're using to discover exoplanets. Planets around other stars also make a little eclipse of a star, makes the light go slightly dimmer. Now, for a planet passing in front of a star, the amount of dimming is really, really minor, and you have to have some specialized equipment to notice that. But this one's actually visible to the naked eye. So I hear, as I say, I've never done it. So that's the challenge for this month, is to see if you can see Algol and see if you can see it dimming and then coming back in brightness again. Just in a moment, I'll show you the dates on that. Before I move along from this map, the other challenge object is down here, which is another little nebula, NGC 1491, also called the Fossil Footprint Nebula. So let's go on there. So for Algol, it just happens that there is going to be three of these eclipses on the 8th, the 11th, and the 13th this month that happen at a more convenient time during the night. The first one, yeah, not so convenient, 3 in the morning, but on the 11th, just after midnight. So that would be Thursday night going into Friday morning. And then on the 13th, 9 p.m. Couldn't be more convenient, given the weather. I believe it's about a couple of hours, the duration of the eclipse. So you'd have to sort of start sometime more like 7:30, 8 o'clock, something like that, and then watch it until about 10:30, 11 o'clock. The times you're getting there? I think that's the center of the eclipse. But a lot of this information is printed monthly in Sky and Telescope magazine. You can also go online to Sky and Telescope's website and look it up as well. Okay, Observer's Handbook as well. Lovely. And the Solar System Challenge is what you've been seeing people trying so hard on so far. Comet C 2023-A3, Shuchin-san Atlas. I sketched this map myself. There's lots of maps available again online. It won't really be easy to see until about the 12th or 13th of October in the evening sky, way down near the horizon. And if you take a look, if you can see Venus, then sort of move to the right and you may be able to see the comet. Both Venus and the comet will be getting higher and higher in the sky from the 12th onward to the end of the month. So it should get easier and easier to see against the twilight, but the comet will be fading. So you might need binoculars, you might need a telescope to actually see it. And we just don't know. But it has a chance of being a really good one. So let's see next month how many people can get pictures of this comet. And we're still waiting. Hasn't blown up yet. Okay, thank you very much and good luck.
Thank you, Richard. Alrighty, so quick overlook of next month's program. Still trying to nail down a couple of speakers, got some potentials, but if there are any more volunteers, I wouldn't mind. Otherwise, business as usual. Rick? Yes. Oh, T-call ball has blown up.
No, it hasn't.
Yeah.
No, it's still boring. But all this talk about Tsuchinshan Atlas, there's been another comet that was discovered, I think, on the 27th of September. This is, it's one of the Kreutz Sungrazer comets. So this was a mega comet that 1,000 or something years ago broke up into a whole bunch of pieces, and gradually the pieces are flying in towards the sun. They come in very close to the sun's surface, so most of them just evaporate. A lot of these you see on like the SOHO images of the sun, and you'll see this big spectacular comet just disappears because it vaporizes as it goes by. This lump seems to be larger than most, so don't quote me, but it's not impossible that it could be a very impressive comet. It's C 2024 S1 Atlas. Just look it up online, keep track, pay attention to the news, because it'll be a very short-lived thing. It's very low in the dawn sky, so it may happen. Keep an eye out for it. It'll be spectacular, if it's spectacular.
Well, thank you for that professional insight, Rick. Okay, Stell's pick for the month, Under Alien Skies. If you're interested in it, you'll find her at the back here at the library at the end of the show, behind the curtains. Space Outreach Week, or Public Outreach Week, or Public Outreach for Space Week. You've heard this mentioned earlier. Chris tells me that there are still a couple of days where volunteers would be appreciated. That's Sunday, Tuesday and Thursday, I believe. So if anyone is would like to help out with this, I guess you can contact Chris at secretary@ottawa.rasc.ca and get yourself organised. Members only observatory, Fred Lossing, members and guests. Your next opportunity is tomorrow night. I have no idea what the prospects for weather are, but it's a go, good. Okay, because it was looking a bit doubtful tonight. But thanks to the usual suspects. Thanks to all our speakers tonight, and especially if we're trying to keep it short. I know we've run long, but there was a lot of material. Thanks to the Chasm staff and Chris up there in his little heaven. And any comments, criticisms and whatever to me, please, at meetingchair@ottawa.rasc.ca. Beers and cheers and good company and conversation at Liam Maguire's after this. I think I need a beer. And next meeting, Friday, 1st of November. I've been asked to advise that the organisation might be a little bit different as far as parking arrangements and activities going on in the foyer coinciding with that meeting, but we're definitely going to be here rather than on Zoom. So wish you all good night. Thank you for your patience. Thank you for your contributions, and see you in November. Cheers.